Well, hello guys, here Mr. G, and we're going to be doing some other videos for grade 12. This time we're going to be talking about work in physics and network. This is the topics that is supposed to be done in the second term of the schooling year and is a little bit tricky. So we're going to be doing this video. It's not going to be that long. We're going to just define work, learn how to calculate work, and then see what is network. And we're going to start straight on with the definition of work. Alright, so now the definition of work, in which in this case you need to know that the symbol for work is going to be W. W is going to be the symbol for work here, done by a force. In other words, the force or a force is the one that do work. Okay, let's fix that on there. Is the one that do work. Is the scalar quantity equal to the product of the force multiplied by the displacement of the point of application. So we can say that W or work is going to be equal to the product, as they said here, of the force, any force, I'm talking about any force, multiplied by the displacement, the symbol is X, of the point of application of the force by the cosine and the cosine of theta. Okay, now where theta here is the angle between F and delta X, or displacement, that is theta. Now we know F is force and delta X is displacement. Now something important which is being mentioned here. For work done by the force is a scalar quantity. So what does it mean? It means that do not have direction, only magnitude, no direction required when you calculate the work done by any force. Okay, so let's look at one example to understand this definition and how to do the calculation. This example is a very simple and say the man cleaning a frictionless floor. So in this floor, in this specific floor, friction is equal to 0. There is not friction. Pulls a vacuum cleaner with a force of magnitude F, 15 Newton at an angle of 30 degrees. As you can see here, there is the applied force in that angle there. Maybe we can use another color. This is the applied force here, as you can see. That is the applied force, which is equal to 50 Newton. Okay, now with the horizontal, calculate the work done by the force of the vacuum cleaner, as the vacuum cleaner is displaced 3 meters. So the vacuum cleaner eventually is going to move from this point to any other point which is a 3 meters distance. That is going to be the displacement of the vacuum. Calculate the work done by the force on the vacuum. Now, in this work, we are always going to try to do the free body diagram of the object, and we are going to include the axis. So I am going to include the x-axis and the y-axis. Now, in the x-axis, this is the x-axis. This one will correspond to the displacement of the object, because we need to know angles here. So this x-axis will be the displacement of the object. And let's see what forces are acting there. First of all, the applied force, which the applied force have an angle. This one is the applied force, and the applied force have an angle of 30 degree with the displacement. This is the angle with the displacement. What other forces are acting there? We also have the normal force and we have the weight. Those are the three forces acting there. Okay, now they ask you to calculate the work done by the applied force, guys. So if we apply the definition here, we have that the work done by the applied force, I'm going to write it like this so we know this work I'm calculating is for the applied force, is equal to the product of the applied force multiplied by the displacement multiplied by the cosine of theta. Theta is the angle between the applied force and the displacement, and as you can see here is 30 degrees. So this is quite simple, guys. The work done by the applied force is equal to the product of 50 multiplied by 3, which is the displacement, multiplied by the cosine of 30 degree, which is the angle between the displacement and the force. Okay, so when you calculate this one, the answer is 129.9 joules is the unit for work. Joules is the unit for work. Okay, so this is the answer for the calculation of the work done by the force. But now that we are here, let's quickly attempt to calculate the work done by normal and the work done by weight. So the work done by the normal force is equal to the product of the normal force multiplied by the displacement multiplied by the cosine of theta. Okay, so now this theta is not the 30. This theta is the angle between the normal force and the displacement. Okay, now if we go here to the free body diagram, please note the angle between the displacement, which is the x, and the normal force is 90 degree. This angle here is 90 degree. Okay, and if we go to the displacement, is also 90 degree. If you're looking down here to the weight, you can see that this angle is also 90 degree. Or if you want to be more specific, the angle with the weight could be also all the way around here. As you can see there, you're using the positive direction, and that one will be 270 degree. Okay, so we can use the 270, but let's go to the normal. Now the work done by the normal, when you go to the substitution, obviously we don't have the normal, but we are going to need normal. Normal multiplied by the displacement multiplied by the cosine of 90 degree. And guys, the cosine of 90 degrees is 0. Therefore, the work done by the normal force is going to be equal to 0 joules. In other words, normal does not do work in this case. It doesn't mean that never do work. It means that does not do work in this specific situation we are working with. Okay, and now similar will happen to the work done of the gravitational force. So if you go to the gravitational force and you want to calculate the work done by weight, or gravitational force in this case, is equal to the product of weight multiplied by the displacement multiplied by the cosine of theta. Remember, all the thetas are different because they are individual for each force. And that case is when you substitute then here, you will have that work of the weight is equal to the product of weight. If you want, let's do the following, so in case you need it sometimes. This is weight. Remember, weight is the product of mass multiplied by the acceleration due to gravity multiplied by displacement multiplied by the cos of 200 270 degree. And guys, again here the cosine of 270 is 0, so thus the work of weight also in this case is going to be 0 joule. Important, this that you can see here is for this situation, guys. This is not for all the time. So weight is going to do a work sometimes, even though it is always pointing to the center of the earth. Okay, but you will see certain situation because angles can change. Okay, so this one is the first situation. This is definition of work, product of force, displacement, and cosine between force and displacement. And this is one example to calculate. Let's go to speak about net force real fast. It's very simple. It's very simple, and with the help of this example, you will understand quite well. Okay, so now network. So network, what is network? Network will be the algebraically addition of all the work done by each force. It's very, very simple. Is the algebraic addition, so you're going to add, we're talking about, in other words, if you may, we are talking about network, which can be substituted by total work or resultant work. Let's change that color, network. Okay, and that will be the addition of work 1 plus work 2 plus work 3 plus all the work, guys. Okay, that is network. So if we go back to this example, the network here, if you calculate the network for this example, will be the addition of work done by the applied force plus the work done by the normal plus the work done by the weight. This is the net work, but the work done by the normal is 0 and the work done by the gravitational force is 0. Therefore the net work in this case will be equal to the work done by the applied force, in other words 129.9 joules. And this is how to calculate net work. This is one example in which the question do not ask for network, but we did take and we answer most of the things that could be asked for that question. So this is the definition of network. This is going to be all for now. We define work, we learn how to calculate the network as well as work. We're going to stop for now, and then next video, guys, we are going to look at an example of how to calculate exactly network when the object is on an inclined plane and when the object is on a horizontal plane. We are going to learn also another way of calculating network. This one is not the only one, and then I'll see you next time. But thank you for watching. Subscribe for the channel if you think these videos help, and I'll see you next time. Mr. G here.